Today we're going to be talking about force components in the 2D system. First, let's start by drawing our system. This is going to be a simple system with just an x-axis and a y-axis. And we're also going to have a force vector. And that force vector will be drawn like that. Notice we're putting the bar over the F to indicate that it is indeed a vector. Now this component, since it's up at an angle with respect to the x-axis, that indicates that it has more than one component. So this one is going to have an x component and a y component. Now you'll see over here that I have written F sub x. F sub x is going to be the amount of force in the x direction. Now if we were to draw that on this picture, let's put some dashed lines to indicate where we're going to. This component right here will be F sub x. So basically that is the amount of this force that is going only in the x direction. Now likewise we can have the same thing in the y direction. So you'll see here I have F sub y. So that is going to be the amount of force applied in the y direction. So again, if we draw that on our plot here, we can go straight up, and then we reach up to the dashed lines, which indicates the top of the force, and we will put F sub y. So those will be our two force components for the force vector. Now this force can be expressed as a Cartesian vector using this notation. We've got our y and x components, and you'll see we use the unit vector that denotes the direction of each. So for this part right here, we've got F sub x, that is the x component of the force. We're going to multiply it by a I unit vector, I being the x direction. Now for the y component, we're going to put the y component of force, F sub y, and we're going to multiply that by j, where j is the unit vector of the y-axis. Now in this case we were dealing with a quadrant that has positive x and y components. Now if we're in a different quadrant, our signs of our unit vectors will change. Now let's look at a case where we have several different forces in the different quadrants. So first let's draw one here again. Let's call that F1. Then let's change the color. Let's call this one F2. Put this bar over here on F1. And let's have an F3 down here in this quadrant. So all three of those are going to be force vectors. Now let's split up the components and draw those out and see how they look. So let's start with F1. That's just what we had before. We're going to have an x component on the x-axis that looks like this. Let's call that F1x. And then it's going in the upward direction, so we will have a y component. Let's call it F1y. Now looking at F2, that one is going to the left, so our x component will point to the left, and that'll be F2x. And then the y component will be pointing upward. Let's call that F2y. And finally F3. F3 is pointing to the left, so our component will be going to the left. We have F3x, and then the force vector is pointing downward, so the y component, F3y, will also point downward. So now we've broken up the three forces into their components, and now we can write out the force vector for each of these forces. So let's start with F1. So the force vector F1 would be written as F1x I plus F1yj. And we need to choose the positive unit vectors because again we are in this quadrant where we have positive x and positive y. Now let's go to F2. So for F2 we are going to the left, so that indicates a negative x direction. So we will put negative F2xi. And for the y component, it is going up, which is a positive y direction. So we will put plus F2yj. And then finally F3. Let's write out that vector. So F3, again, we are going to the left, so we will have a negative x component. So we'll have negative F3xi. And this one is pointing downward, so that is a negative y direction. So we will have negative F3yj. So that kind of gives you an idea of how your signs are going to change depending on what quadrant you're working in. Now let's go back to our three original forces, the F1, F2, F3. What if we wanted to know the total applied force on a body due to those forces? What we want to do then in that case is we want to find the resultant. Now the resultant is essentially the summation of forces. So you can see our equation here. We've got a capital R that indicates resultant. Notice that it is a vector. It's got the bar on top. And that is just going to be the summation of the force vectors. So to find our resultant, we are going to add up our three forces. We're going to have F1, F2, and F3. We will find the summation of those. And again, notice these are the force vectors. So now let's take our equations from above and just substitute those in. And if we do that, we end up getting that the resultant is F1xi plus F1yj plus our F2 equation, which was negative F2xi plus F2yj, and then finally F3. So we have negative F3xi minus F3yj. So now that we have this, we want to add up the like components. So you can only add up the components that have the same unit vector. So we're going to look at all of the components that have the I unit vector and sum those up. So we have F1x, and then we have minus F2x. Make sure you carry over that negative sign. And then we have minus 3x. And then we put the I unit vector, because all three of those were I components. And then do the same thing for the y components. So we have F1y plus F2y, and then minus F3y, and then put the j unit vector out to the side, because those are the y components, or the j components. So now that we have this, we can also say that the resultant is equal to r sub x, which indicates that this is the x component of the resultant force. So it is the x component of the total sum of the forces. And then put an I outside of that, and then put plus ryj. So this will be the y component of the resultant force, or the summation of the forces in the y direction. So using these two equations, equation 1 and equation 2, we can say that Rx is just the summation of all of the x components from the individual forces, and Ry is the summation of the y component from each individual force. So that's how we're going to construct our resultant vector. And now let's say we want to have a magnitude. So we want to get rid of the direction. We just want to have an actual number. So to do that, we're going to find the magnitude of the resultant vector. And the magnitude of r will be calculated by saying that r is equal to the square root of the x components of r squared plus ry squared. And notice there is no bar on top of this r. That indicates there is no direction. It's just going to be one number. Okay. And this is how we would calculate the magnitude. Now, let's say our resultant force is in this direction, and we need to find that theta. We can find this theta using our Rx and Ry values. And we can do that looking at this right triangle. So if this would be r, this leg of the triangle here would be rx, this would be ry. Here's our angle theta. So to find theta, we can say that theta is the arc tangent of ry over rx.